Between Mars and Jupiter is a region of space that has intrigued scientists for centuries. Could there be a mysterious planet hidden in the asteroid belt? The idea is not new. It dates back to the 18th century, when two German astronomers, Johann Daniel Titius and Johann Alert Bode, proposed a mathematical rule that suggested the existence of a planet between Mars and Jupiter. This rule, now known as the Titius-Bode law, made it possible to predict the distances of planets from the Sun with remarkable accuracy. According to their calculations, there must be a planet located exactly where the asteroid belt is located. For years, astronomers have searched for this elusive planet. They have found many small objects in the asteroid belt, the largest of which is Ceres, a dwarf planet about 940 kilometers in diameter. But is Ceres the missing planet, or is there something more? Recent discoveries by NASA have reignited this centuries-old mystery, suggesting that there may be a much larger object in the area, a planet that was destroyed in some way. Picture the scene: the James Webb Space Telescope, with its unparalleled ability to peer into the depths of our solar system, is gathering new data. NASA astronomers analyzed the images, their faces illuminated by the glow of their computer screens. As they scrutinized the data, they realized something surprising. Evidence suggested that this was not a simple asteroid cluster but the remains of a once great planet, shattered by a cosmic catastrophe. The idea of a planet in the asteroid belt had fascinated scientists for centuries. In the 18th century, the mathematical rules of Titius and Bode led to a frantic search for the missing planet. When only smaller objects were discovered, the dream of discovering a new planet seemed doomed. However, modern calculations have breathed new life into the theory. Careful analysis of planetary orbits, combined with advanced astronomical techniques, has provided compelling evidence that there should be a planet between Mars and Jupiter. The asteroid belt itself is a chaotic region, filled with hundreds of thousands, if not millions, of pieces of rock and metal. These objects range in size from tiny dust grains to larger objects like Ceres. The unusual shapes of these asteroids suggest they are fragments rather than entire planets. But what could cause such great destruction? According to one theory, the asteroid belt is the debris of a planet destroyed by a massive impact. Imagine a time, billions of years ago, when our solar system was a place of violence and chaos. Protoplanets collide and the remains of these collisions are scattered throughout space. Could such a collision destroy a planet in the region that today occupies the asteroid belt? Computer simulations support this theory. They show that the chaotic distribution of asteroids and the large amount of material in the belt are compatible with a catastrophic event. The kinetic energy of a collision strong enough to shatter a planet would send debris flying in all directions. Some of the debris would remain in the asteroid belt, while others might be ejected from the solar system or pulled toward the Sun. But not all scientists agree with this theory. Some believe that the gravitational influence of Jupiter, the largest planet in our solar system, prevented a planet from forming in this region. Jupiter's immense gravity may have disrupted the accretion process, scattering the planet's building blocks and preventing them from merging into a single mass. This theory is supported by the diverse composition of asteroids in the belt. Analysis suggests that these objects have different origins and formation histories, which would be unlikely if they were all fragments of a single planet. The debate continues, but one thing is certain: the asteroid belt holds clues to the ancient history of our solar system. It is a mysterious and fascinating region where scientists continue to make new discoveries. The James Webb Space Telescope, with its advanced capabilities, is poised to unlock more secrets about this mysterious part of space. Now imagine NASA's excitement when new calculations by scientists suggest that the rocks between Mars and Jupiter are not fragments of a destroyed planet, but the building blocks of a planet that was never completed. This theory, reminiscent of ideas proposed by Titius and Bode, suggests that a planet should have formed from the mass already present in the asteroid belt. But Jupiter's immense gravity disrupted this process, preventing the material from coalescing into a single object. As the evidence mounts, the question remains: what really happened in the asteroid belt? Was a planet destroyed by a giant impact? Or did Jupiter's gravity prevent a planet from forming in the first place? The answers to these questions could reshape our understanding of the early solar system. Think about what these findings mean. If a planet were actually destroyed, what force could have caused such a catastrophe? The early solar system was a chaotic place, with planets and protoplanets in unstable orbits. Collisions were common, and the remnants of these collisions can still be seen today. One theory is that a planet in the asteroid belt was hit by another large object, causing it to shatter. The debris from this collision would form the asteroid belt, some of which would remain in orbit, while others would be ejected from the solar system or pulled toward the Sun. Another possibility is that the gravitational influence of a large nearby object, such as a passing star or a rogue planet, disrupted the orbit of a planet in the asteroid belt, causing it to break apart. Such events are rare, but they have probably occurred in the history of our solar system. But what if the asteroid belt is not the debris of a destroyed planet, but the remains of a planet that never formed? Recent calculations by NASA suggest that material from the asteroid belt could be the building blocks of a planet. However, Jupiter's immense gravity disrupted the accretion process, preventing the matter from coalescing into a single object. This theory is consistent with the Titius-Bode rule, which predicts the existence of a planet between Mars and Jupiter. The discovery of water, organic matter, and possibly an underground ocean on Ceres by NASA's Dawn space probe adds another layer of intrigue to the mystery. Could Ceres be the remnant of a planet that was never fully formed? Or is it a unique object that formed early in the solar system? The presence of water and organic matter suggests that Ceres may have been geothermally active in the past, suggesting a complex history. As we delve deeper into the mysteries of the asteroid belt, we must also consider the broader implications for our understanding of planet formation. The processes that form the asteroid belt can provide valuable insights into the ancient history of our solar system. Studying these objects can help us understand the conditions that led to the formation of planets and the dynamic events that shaped their evolution. The asteroid belt remains an area of great scientific interest, and future missions will continue to explore this mysterious part of space. Thanks to advanced telescopes and spacecraft, we can uncover more clues about the history of our solar system and the forces that shaped it. In short, the mystery of the asteroid belt remains unsolved. Whether it is the debris of a destroyed planet or the remains of a planet that never formed, the evidence continues to intrigue and challenge scientists. Discoveries made by NASA and other space agencies have shed light on this fascinating region, revealing the complex history of our solar system. As we continue to explore the asteroid belt, we may one day discover the truth about its origins and the forces that shaped it. Stay tuned to our channel for exciting updates on this and other astronomical mysteries. Many more discoveries await us as we continue to explore the wonders of our solar system and beyond.